Hey everyone, it's Mrs. Hartley. It's been a while since we've done an explore like this one. It kind of takes me back to the very beginning of the year. But the assignment this time is going to be entirely in Google Classroom. And the reason for that is because STEM had two longer, a little more involved explorers that I have combined here into shorter, I think, hopefully a little easier to understand exercises that will allow you to both play with weather prediction and with some of the probability calculations that they'd like you to experiment with. So, right now, my screen, I know your screen will look a little different because you'll have the tutorial video. But right now, what I have here is the actual document that you'll be working in. So, your name should be on this one. And then there's also a PDF of the weather prediction map. So I do recommend that you go ahead and open them both. I have my demo up here, but I'm going to go ahead and open this up too so that I have that. And I'm just going to kind of keep this over here so I can refer back. The reason why this is important is only because you can see these little numbers here, 75, 50, 75. Those are kind of hard to see on the document. So it's important to just know what's there. But this is supposed to be a map of the United States, I guess, on a Monday, on a random Monday, I guess. And so we have a cold front that's kind of passing through here. So there's kind of a cooler air mass that's making its way this way into warmer air. And its temperature is 50 degrees. And right along that front line, they're experiencing some thunderstorms. And up here, we have a warm air mass that is coming in on that cold air mass. So that's somewhat warmer. It's 75 degrees Fahrenheit. And along that front, they're experiencing some rain. Now we know that in between, the weather should be pretty clear because when you're in the middle of an air mass, there isn't really a lot of rain. The rain is only going to happen when the fronts are crossing over a given region. Okay, so we're going to keep that in mind as we go into our Explorer. And your Explorer looks like this. So the first page has this data table on that we need to fill in. The second page has that same map, but of course it's been pasted in, so it's a little blurrier. And up here we have some manipulators. So this is a ruler, and then we have, these are other front lines that you can use and put on the map to help you decide what's going to happen in the city that we're looking at, which in this case is Omaha. Okay, so we're going to be looking specifically at Omaha for this particular exercise. Page 3 has some questions, which we'll go over as soon as I do the demo. Then part 4, page 4 takes us into part 2, and that's where we look at some probabilities based on a spaghetti model like we discussed in class. So backing up here, one thing that might help you is to go up here and right click or double click and hit duplicate just to open the same document in a second tab. So what I recommend you do kind of is do the pull down, click it and drag and then split your screen just so that you can see both at the same time. Now you still want to zoom in a little bit, just if you can. I know it's a little touchy here because we're now, dealing with a smaller window, but just remember that if you want to view it in full screen mode there, that kind of helps a little bit by getting rid of some of the stuff up top. But you'll still have to do some scrolling back and forth. Okay, so our first order of business is to put the front lines where they need to go on the map. And to help with that, down here, they've given you the front speed, which is 11.14 miles per hour. So it's about 348 miles per day, and so on. Now, that's a little hard to manage. So we have this, this ruler here, and this ruler can be moved around. It's a little bit translucent. You can actually see through it just a little bit. What I'm going to suggest you do, if you hold down Shift while you pull on this rotate button, it will actually rotate it to specific amounts. And I think 45 degrees is what you want. And then you can move that. We're going to do, I guess we'll do the cold front first. You're going to put it right along there so that you want the 0 to match up with the front line. That's right where it is, with the front tail right there. Because what that allows you to do is to kind of glance over here and say, okay, so 384 miles per day for the cold front, that means it's going to go 1.7 centimeters. And we're going to drag one of these down and put it about 1.7, kind of right in there. Now, it's not absolutely vital that you be precise with that. It just needs to be kind of in the general area. This one, the second one, it says 4.4. The truth is, it really should probably be more like 3.4. I think I did a calculation error there, but it's not going to be like, you're not going to get anything wrong if you did it the way I wrote it. We're going to move this down to 5.1. And then this one comes down here to, 7.7, 8.1 right there. Okay, so we can see how that air mass would be moving. So this is Monday, that's today. This is going to be Tuesday, Wednesday, Thursday, Friday. Then you want to do the same thing with the warm front. So I'm going to move this up here and place it where it goes. And we're going to look here. We have 1.5. So we're going to put this at 1.5, sort of right in between. The second one would be on Wednesday is going to be 3.1. So we're going to move it to 3.1. And then on Thursday, we're at 4.6. Down there. And then on Friday, 6.2. So I'm going to move this down to 6.2. Okay, so you can see now it looks like they overlap each other. So we're going to have to remember that we're looking at sort of a time lapse of what's going on. Okay, so I put my ruler away. So now I've got my fronts in place, and we're going to have to assume that this line, this front line, is actually extending all the way up so that it is passing over Omaha on certain days. Now, we have to make kind of a prediction. So now that we know what happened, this is Monday, Tuesday, Wednesday, Thursday, Friday, and then this one's also Monday, Tuesday, Wednesday, Thursday, Friday. So looking at Monday, which is exactly what's going on in Omaha right now, okay, and if we look in, if we kind of zoom in on this map here, let's zoom in right here, we can see that Omaha is currently experiencing some pretty sunny weather, and it's 75 degrees. So our temperature in Fahrenheit is going to be 75. Precipitation prediction is that it's going to be sunny. There's not going to be any rain. And the probability of rain is going to be very low because there's no front passing over Omaha right now. The rest of this is already filled in. But now we have to look at Tuesday. All right, so Tuesday would be this front. This front's going to be here, and this front's going to be back here. So on Tuesday, the warm front is too far back to really affect Omaha, but it's probably starting to get a little cooler now because this cold front is moving in. Now, it's probably still not quite the same, but since it is getting close, they're probably going to start experiencing rain here pretty soon. So the temperature is probably going to be in the 70s. We'll say maybe put 70. And remember, notice there's not a particularly right answer. There's just logically, we know it'd probably be similar, but a little bit less. The precipitation prediction is probably going to be some rain, maybe some storms. The probability of rain is probably going to be it's going to be high that day. Then we get into Wednesday for that. Okay. Now on Wednesday, the cold front is passed over. The warm front is just approaching. So right now it's kind of in the middle of that cooler air mass. So we know that this temperature has to be even lower. And since we know that where that temperature was, and we're going to look here just to be clear, that cold front has a temperature of about 50 degrees Fahrenheit. So we're going to assume that this is probably in the 50s, or so we're going to say 50 degrees Fahrenheit here. The precipitation prediction at this point, though, because again, we're dealing with this cold and this warm, that means that it's kind of in the middle of that air mass. So it's probably sunny again. It's just cooler. The probability of rain is going to be low because we are on Wednesday between this air mass and this front and this front. So Omaha is probably not experiencing anything because it's between two fronts. Okay. Come Thursday, we're looking at the fourth line for each one. At that point, the warm front is lined up right with Omaha. So now it's going to start getting warmer. So if we check back here, we see that that's back at 75 degrees and it's rainy. So we're going to say that this one is 75 degrees again. Precipitation is rain. And the probability of rain there is high because we have an air mass that's flying right over us. And then finally on Friday, the warm air mass has passed us by. The cold air mass, we're in the middle of the warm air mass, but the front has passed us by. The cold front is way down here. So we're going to say that it's probably still 75 degrees, that it is sunny, and that there is a low chance now of rain. Okay, so that's what you want to complete for that one. Then you're going to come down to page 3, and I'm actually going to go ahead and close my second window now because I don't need it anymore. And we're just going to look at these questions together. I want to read them out loud so that you can hear them as well as see them. So question 1 says, when did the cold front pass over Omaha? So you want to tell which day it was that the cold front got close enough to pass over Omaha. And then what weather did Omaha most likely experience when the cold front arrived? So you're going to want to maybe check back on our notes from today. Today was Tuesday. That would be the day 12 notes. And just see what kind of weather typically is associated with a cold front. Question 2 says, when did the warm front pass over Omaha? And then what weather did Omaha most likely experience when the warm front arrived? So same thing. This is also in our notes. The day the warm front arrived would be on our map. And then what weather did Omaha most likely experience? Again, check your notes and see what the weather is typically like under a warm front. Question 3 says, what data was most important in making predictions about Omaha's weather conditions? Okay, so when we're looking at this and we're looking at what we're going to predict, what is it that we look at to determine what weather is going to be like that day? And then number 4 says, both the warm front and the cold front brought rain with their passes. What is the difference between the two? Okay, so what was the difference between the type of rain that came with the warm front versus the cold front? And then finally, can we be positive that your prediction is correct? Okay, is there a way that we can know for certain that what you predicted will happen in your data table is actually what's going to happen? Okay, so that is all part 1. Part 2 involves this spaghetti model. So again, it might be helpful to go ahead and duplicate your tab so that you can have it open twice. I'm going to go ahead and move that one to one side and move this one to the other. All right, so in this case, you're looking at this map of a hurricane. And as we discussed in class, sometimes scientists will use computer models to help predict the path that a storm like this might take as it approaches a body of land or something like that. So there are 14 different colored strings here. We have an orange, a brown, a pink, a blue, a black, a red, green, maybe a gray, I think that is, a darker green, a darker gray, a yellow, and then this kind of indigo one over here. And what, in theory, this would be is the computer has tried to take into account all of the different things that could be affecting which way this hurricane goes from where it is right now. And taking into account all those things, there's 14 different ways it could go. So we have to calculate the probability that it's going to go any one of these particular directions, and then talk about what that then means. Like, what do we do once we know that? So if you go to the second page, we have some questions here. Now, in my case, I can actually adjust the size of these. I realize on your Chromebook, you may not be able to do that. But that can kind of help me read these questions out loud to you. So you're going to use the information in this model, to calculate the probability that the storm is going to make landfall in Texas. So Texas is here. That's the state right here. And so we have 14 different scenarios. The first one that they gave an example up here of Florida. So in the chances, the probability that it could hit Florida is basically 1, because there's only one path here that goes into Florida, 1 out of 14. Okay, so when you're going to calculate a probability, you would say, well, what is 1 divided by 14? And what you get is 0.07. That means that there is a 7% probability that the storm was going to make landfall in Florida. Okay, so what we want to do is do that same thing with Texas. Okay, so what we want to do is we want to look at the Texas border here. This is where Texas borders the Gulf, and count how many of these lines actually cross into Texas right at the coast. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I count 10. So there's the green one, the gray one, the brown one, the red, the lighter green, the black, the light blue, the pink, the tan, and the orange. So that's 10. So that means that we have 10 out of 14 scenarios. So what is 10 divided by 14? So we can go to google.com or use a calculator on your phone, whatever you want to do for Google, and put 10 divided by 14. Right, that gives us 0.71.4. 0.714, blah, blah, blah. So we're going to use the first two there. So we're going to estimate 0.71. So 10 by 14 equals 0.71. There is a 71% chance that the hurricane will make landfall. That means that's what we call it when a hurricane crosses over onto the land in Texas. Okay, so you're going to do that same thing again now, but instead of looking at where it crosses onto land, we want to calculate the probability that the hurricane will move into or through Missouri. So we want to count how many of those scenarios actually bring the hurricanes. Now, by the time it hits us, it would not be a hurricane. It would just be a bad storm. But how many scenarios actually bring some of that storm into Missouri? So you want to count how many lines are in our state and then do the same thing. So this is all I need in terms of showing your work. I want you to tell me how many out of 14 and then show me the calculation. And it is fine with me if you use a calculator. That does not bother me at all. In your math class, you have to follow what Ms. Linder says. So don't, this is only for here. All right, so then then you need to answer, why is it important to know the probability that a hurricane might make landfall in one state versus another? So think about why we would care in this case, where this is going to land. And I mean, hopefully some of that's pretty obvious, but give it some thought, and that's what you want to write there. And then for question 4, based on this model and your calculations, what actions should we now take? What should be our next step to limit the destruction caused by this hurricane? And in what state should we focus those actions? So think about, what is the next step when you know a hurricane's coming? And those of you that studied hurricanes during natural hazards probably have a leg up on this one. But based on that, where should those efforts be centralized? Okay, and that's it. Once you're done, you just turn it in. If you have any questions, please send me an email, chat with me via GoGuardian. I am happy to help. Good luck.